Hi everyone, today we are going to solve one of the induction question. So I put my steps over here. So let's read the question. It is given that 2 cosine A sine A is equal to sine A plus B minus sine A minus B. Now use mathematical induction and above identity prove that sum from n to r equal to 1 is equal to sine 2n theta over 2 sine theta. Okay, so in this type of question, if it is an induction question, always use these 3 steps. Okay, so the first step is you always consider P1. P1 means like you just plug in 1 into R in this case. So 2 times 1 will be 2 minus 1 is 1 theta. So left hand side will be cosine 1 theta. In the right hand side, if I plug in n equal to 1, you will see this is going to be sine 2 theta over 2 sine theta, right? And these 2 sine theta and this one will cancel each other. I'll get only cosine theta. So as you see, left hand side equal to right hand side. So step 1 is done. This is just 1 mark. Now the step 2, assume pk is true. So this is important because I'm going to use this assumption to prove this identity. So if pk is true, it means when n equal to k, this is always going to be true. So I just need to replace n with k. So instead of n, I'm putting k, as you see, cosine 2r minus 1 theta. I didn't change anything in the r, but I need to change n with k. So sine 2k theta over 2 sine theta. So let's keep this one here. I'm going to use it. And step 3, my purpose is to show that it is also true when n equal to k plus 1. So that's why I'm going to consider pk plus 1, and I want to show that right hand side in the end will be sine 2 times k plus 1 theta over 2 sine theta. Let's write theta here. Okay, so why did I change n with k plus 1? Because I want to show that it is also true when n equal to k plus 1. So that's why I replace n with k plus 1, as you see over here. So I change it. So now let's go back and start working on this one. So basically k plus 1 and from r equal to 1 cosine 2r minus 1 theta. Okay, this is equal to the sum formula from k to r equal to 1. This is the previous term, cosine 2r minus 1 theta, plus the second term will be n, which is equal to k plus 1. So instead of n, I'm going to put k plus 1. Look, here you may consider r as n in this situation. So the next part will be 2 times k plus 1 minus 1 theta. You just replace r with k equal r equal to k plus 1 theta. Now, as you see, this one, according to my assumption from step 2, equal to sine 2k theta over 2 sine theta. I just replace it with this one, plus cosine, the same expression over here, move over there. Okay, so now I'm going to use basic algebra in this case. Just remember, let's say 3 over 5, it's just an example, plus 4. How do we do this easily? We just keep the denominator same, right? 5 times 4 and 3 plus 5 times 4. So 3 plus 4 times 5, which is 20. Right? So let's use this technique for this question. So I'm going to multiply 2 sine theta with cosine 2k plus 1 minus 1 theta, which is over here. And I'll add sine 2k theta. So sine 2k theta, which is here, plus 2 is the same 2 here. And sine theta, I move sine theta behind. So 2k plus 1 minus 1 theta, it's over here. Now, I need to do some simplification over here. So 2k plus 1 times theta is 2k theta plus 2 theta. When you expand this, you get this expression. And in this case, you get sine 2k theta. So let's check this part. So 2k theta, sine 2k theta, will cancel with negative sine 2k theta, and I will just get this one. Sine 2k plus 2 theta over 2 sine theta. In this type of question, always remember you can move the 2 outside. If it was 3, then you can move 3 outside. So I'll move 2 outside. And inside I get k plus 1 theta. So proof is done because we just showed us that's the same as this one over here. So left hand side equal to right hand side. Please write this expression once you finish your proof. This is very important. You can use this for any other induction question. So pk plus 1 is true whenever pk is true and p1 is true, so pn is true, and for all the positive integers. Okay, so I'm going to solve different types of question on induction. Please check the other videos. Thank you for watching.